All right, it's your boy the Canologist, and we're going to be doing the question: construct the rectangle. A web developer needs to know how to design a web page's size. So, given a specific rectangular web page's area, your job is to design a rectangular web page whose length L and W satisfy the requirements. The area of the rectangle. The area of the rectangular web page you design must equal the given target area. The width should not be larger than the length. Difference between L and W should be as small as possible. Return an array where L and W, the width and length of the web page, are designed in sequence. It's kind of a weird question. Errors for 2-2. The width should not be larger than the length. Oh, so you can't have like I think this is like a factor question. You have to find all the factors. And none of the factors that end up where the width is greater than the length could be acceptable. What about finding factors? Factors of x are 0 to x plus 1. Oh, okay, so this is how you find factors. So find the things where remainder equals 0. So let's create a list. Let's call this factors. Then I'm going to go for I in zero to area plus 1. Because I want to go from 0 to area. If area divided by I percent 0 remainder. Oh wait, if area percent I equals 0, like here, this equals 0, print I. So this is going to be add to factors. So basically what I'm saying is find all the possible factors of 4. They give remainders of 0. So let's look at, for example, 37. All right, let's take 37. Let's go to Python Playground. Delete x equals 37. And then let's just copy the code. For I in range. It's got to be range. See, this is a good thing about using tools to check. You can figure out exactly where something's going wrong. For I in range 0 to x plus 1. For I. Oh, this whole thing's indented unnecessarily, so that's probably why. So I have to go here, Shift Tab. Then x. Oh, and I can't go from 0. It's got to be from 1. Nice. See, look, I'm like smoothing it out as I go. So you don't even need to know how it works. The compiler will pretty much tell you where to start. So 1 and 37, there we go. So the next thing is once I have my factor list, it should say difference between L and W should be as small as possible. So if we look at the factor list, because L and W there's only 2 factors, you will only get 37 and 1, right? So let's say if it was area, let's see this. Let's just take this now that we have it. I just want to analyze the factors. Now we just apply it. Okay, so now we have to find what is the ideal. So what I'm going to do is I'm going to pair each factor. Factor pairings. Right, so now that I have the factor pairings list, what I want to do is I want to combine them. So I'm going to say L and R. So L would be lowest. L equals 0. R equals what's called factors. So let's cut that out here. Let's paste that here. Factors. Len factors -1. So create a factor list, factor pairings -1, and then I'm going to say while L is less than we can't have the same number for L and R being a pairing. So what I'm going to do is while L is less than R, we're going to say because it's going to have at least 2. There'll always be at least 2 factors to a number, itself and 1. So like we saw with 37, it'll have at least 2. So while L is less than R, this is a really inefficient way to solve it, but I'm just going to do it this way. This is where my brain's going. So while L is less than R, I'm going to go factor. Factor pairings dot append factors R. What's the R is going to be the length and the width. Length and width. So R is going to be the length. So R is going to be the length. R is going to be the length. R, comma, factors L and R. So that means it's going to keep pairing until it gets to the middle. Then we stop. So now we have our full list of factor pairings. So I'm going to build this on Python Playground and check it. I'm just going to keep building and checking as we go. So right now, Control V. So there's that. The next thing is this LR thing, LR thing. So Control X, first I want to print the factors to show them. Then I want to print factor pairings. Make sure things are working correctly. I'm just showing you guys how to build your code and test it as you go. It's not perfect, but it does the job. It does what it needs to do. Oh, it's still running. Oh, I need to stop it. So let's see, this is another good indicator. Now that I'm building and testing as I go, I need to know that I have to increment L plus equals 1, R plus equals 1, so we don't get into an infinite loop. No, minus equals 1 for R. So minus equals 1 for R. So that way they come like this. I have to imagine my pointers. You have to use your imaginations. So it's going to be L plus equals 1, R minus equals 1. That should be there. So as you can see here, it's 1,222, 1. So we got this whole list. I print a space here. So now you can see this factor list. You see here? So the one that's closest, the one with the smallest difference will probably be the last pairing. So all I have to do is go get this number, 427 and 286. And if I look at here, it should be 427, 286. So now all I have to do is go to my factor list, return, factor, pairings, -1. That should solve the problem. Oh, wait, minus equals thing, network error. What? Wait 1 sec, let me save all my code just so I don't lose it. What the fridge? Python. I'm solving in Python. No, what's going on here? Python. V. Delete this. Okay, let's run my code, reconstruct the triangle. Reconstruct the rectangle, I mean. Okay, Leetcode is bugging out. Okay, let's go to the problem list one more time. Construct the triangle. Let's just start again. I pretty much solved it. That's the stupid thing here. Like, I put in all this time to solve it, so it's like, you can't just take that away from me. Difficulty easy, algorithms. Why is it doing this? Why is all my progress gone? Oh no. 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 This can't be happening to me. This can't be happening to me. Let's just let's try it out. Hopefully I didn't lose everything. Okay, we're getting somewhere. Okay. This looks to be a bit better. Difficulty easy algorithms. Okay, now let's go to here. To reconstruct the rectangle. Okay. Did it save my code? Yes, it did. Okay, let's run my code. Okay, so return factor, pairings. Okay, so what happened here is basically what I did here was I returned this. It says the difference between L and W should be as small as possible. So when you look at the first element, that's actually the furthest it can be, right? So if you look at the element closest to the middle, that's as small as it can be. So all you have to do is take the last element from here and you can return it. So what I'm going to do is, I think I misspelled it, that's why. Factor pairings, this should, so all I'm going to do is take the last element of this factor pairing list that I constructed and return it. And that should be done the problem. Worst case, so 4 and 1, expected 2 and 2. 4 and 1, expected 2 and 2. Okay, let's try 4. Let's try 4 over here. And then what I'm going to do next is I'm going to print first. I'm going to print an empty line because I want to space out so you guys don't get confused. Print a spaced out line and then print factor pairings -1. So run it. So okay, all you have to do then is this. I'm just curious. Factors. One, two, four. Okay, so if I made it equal to, so if I did this, you'd have 2 and 2. Okay, so all it does is, because it's coming up to here, it can't go on that odd element. So what I need to do to fix that is I just need to adjust this to make it less than or equal to. So I get the 2 and 2 case. This should pass all the test cases. And I can submit it. I thought I lost all my progress for a second. I'm like, I thought Leetcode like refreshed me. But this should fix everything. And there you go. Beats 7.04%, and I showed you how we could systematically break things down. So let's go through the top again and I'll explain what I did. So it says area of the rectangle must be equal to the given target. Okay, so it means length times width has to equal area. That's the standard rectangular formula. Here it says the width should not be larger than the length. So it means L should be greater than or equal to W. So as close to or equal to W. So that right here tells you that you can make this L and R left and right equal. Difference between length and width should be as small as possible, right? So what this tells me right here is return an array where length and width of the web page. So here what gave it away for the factors and how I thought to look at factors was when I looked at the example. So target is 4 and all the possible ways to construct it are here. All right, so because I don't want repeats, what I did was I want to find all the factors. Right now this is all the factors and combinations of those factors, right? So I don't care about combinations in this case. I don't want repeats. So I want all the factors but no repeats. So I'm going to go left and right and just keep pairing them. And that way each thing can only be used once, right? The second thing is I want to make sure that what's called R is greater than L. So I'm going to pair it, putting the R on the left side and the L on the right side. So if you look at my factor pairings, I paired them with R on the right side, the right, which is length, according to this example, and width on the left side. No, width on the right side. So R on the left, R is the right side length, but it's L. Right, because you want the larger number to be on the left, and all the numbers are going to tend to be on the right side. So I'm going to flip it, put my R factors on the left side, and my L factors on the right side, right? And then The next thing is let's keep getting smaller so I don't get repeats. So then, like you see here, I get all the pairings, right? And then all you have to do is, once you get all the pairings, return the last one in the pairing list. So the last one is 2 and 2, because when you go through all the pairings list, it matches from greatest, the greatest element with the smallest. So it goes greatest, smallest, greatest, smallest, greatest, smallest. So it's the middle where it's as close as possible. So it's just a no-brainer to take the last element of your factor list. So as you can see, passes all the test cases, passes the submission. So if you like this video for constructing the rectangle, please give it a thumbs up, subscribe, comment below. Knologist out.